Again, let me remind you that geometry is a very organized and logical subject. Because of this, the guiding light for solving geometry problems rely on definitions, postulates, and theorems. Definitions are, for example, what we use for explaining things. A circle is a round figure. You knew that. But did you know that a circle is defined as a line whose points are all equidistant from one point called the center? Or that an angle is formed by two non-parallel rays that meet at a point? These are called definitions. And although you may find it silly to be that precise in a definition, please always remember that that is the nature of geometry. Let's go to postulates. A postulate in geometry is a premise that cannot be argued. It is like set in stone. For example, the postulate, through 2 points only one line may exist, is a postulate because that is the only way it can happen. Or listen to this other postulate. When 2 lines intersect, a point is formed. Or still listen to this other postulate. When 2 planes intersect, a line is formed. So remember, if it is a plain truth, and you can only prove it by common sense, it is a postulate. Now to the theorem. Unlike a postulate, a theorem must be proven. To prove a theorem, you must use definitions, postulates, or other theorems. For example, if I say, if 2 lines intersect to form a 90-degree angle, then all 4 angles in the intersection are 90 degrees each. Notice the if and then format. Now, this is a theorem, and we may prove it informally or formally. I will prove it informally this time, because I haven't introduced formal proofs yet. Okay, remember that to prove something in geometry, you have to be logical and make sense. First, we have to say, okay, I know that by definition, a circle contains 360 degrees. That you know from earlier courses. I will not go now into why a circle has 360 degrees because it is a historical question beyond this course. So, if a circle has 360 degrees, a line has then 180 degrees. Why? Because a line is what you get by cutting a circle in 2. And half of 360 is 180. If a line has 180 degrees, and if I make a 90-degree angle with 2 lines, then other angles on the line must also have 90 degrees. Why? Because 180 minus 90 equals 90. Now, if we apply the same logic to the other 2 angles, where a line is cut by another line making a 90-degree angle, then the next angle is also 90, and so is the 4th angle. What I just did is an informal proof.